Good morning, our students, and welcome to this morning's class. What is before us today, this morning, is to show with you that if a random variable x follows a normal distribution with parameters mu and sigma squared, it implies that expected value of x, which otherwise is called the mean of x, is given as mu, and var of x is given as sigma squared. Do you remember that earlier we said that a random variable x follows a normal distribution with parameters mu and sigma squared? These parameters are, of course, what we call the mean of this normal distribution x and the variance of this normal distribution x. Another name of saying the mean of a random variable is to say expected value of that random variable. And then the variance of this random variable, sigma squared, is what we have here, variance equals sigma squared. So what we intend to show is that if this random variable x follows normal distribution with the mean mu and variance squared, which is expected value mu and variance sigma squared, show that expected value of x bar, that is expected value of the mean of this random variable x, will still give us what? Mu. And then the variance now will give us sigma squared all over n. That is what we want to establish here with you. So permit us now to go through it with you. So I begin by saying solution. Begin by saying solution. Solution. So of course we now begin with e of x squared. So I have what? E of x squared is given as e of sum I runs from 1 to n of what? Xi of xi all over n. Remember that the formula for mean x bar is sum of xi all over n. Okay? This n can actually come outside here. And then what we now have here becomes that this is equals 1 all over n expected value of sum over I running from 1 to n of what? Xi of xi. We close the brackets. Now, when you want to establish this proof, you bring out the sum outside and take the expected value inside. And then, even before we do that, we can equally express this in this way. That this equals 1 all over n expected value, you open a bracket. Sum I runs from 1 to n of xi means addition of what? X up to n times. So this is the same thing as saying x1, it's the same thing as saying what? X1 plus x what? 2 plus 2x what? Xn. You close the brackets. Okay? So this now becomes, this equals now 1 all over n. When expected value comes in here, we have a bracket open and we have e of x1 plus e of x2 plus up to e of x what? N. You close the bracket this way. And do remember that it was earlier given that expected value of a random variable x is given as what? As mu. So this of x1, this x1 is still a random variable x coming from a normal distribution. So its mean is still what? Mu. So what I'm going to have here now becomes this equals 1 all over what? N. I'll open a bracket. Here is going to be what? Mu. For this particular one, plus. For this one, mu plus. Down to what? To this what? Mu. Then you close the brackets. Remember that when you are adding something up to n times, it is the same thing as using n to multiply that thing. What I mean is this. If you have 2 plus 2 plus 2, you want to add up 3 2's. The simplest way of writing it is 1, 2, 3. You say 3 times 2. See here, 2 plus 2 is 4, plus 2 is what is 6. Here, 3 times 2 is what is 6. If you increase it here now to plus what? 2, you are adding 4 2's up. The same thing is for you to count 1, 2, 3, 4, and use 4 here now to multiply the 2. 2 plus 2, 4, plus 2, 6, plus 2, 8. 4 times 2 is what is 8. And here, remember that here is xn. So we are adding up mu's up to n times. For that reason, what we are going to have here becomes 1 all over what? N of n mu. This n mu is the addition of these mu's up to n times. So here I have n and here I have n. This can cancel this. And what I have here left is what is mu. So the expected value of x bar is given as mu. Just the same way that we had that expected value of x alone is given as a mu. So that is how to establish that expected value of when x follows a normal distribution with mean mu and variance sigma squared, that the expected value of x bar is given as a mu. Let us equally now establish that of the variance of x bar. Variance of what? X bar. So permit me to clean this one. Then I recall for you, this is expected value of x bar here. X bar is written as sum I runs from 1 to n of xi all over n. Okay? I brought n outside because the constant outside the summation line and even outside the expected value symbol. Then I had 1 over n, expected value of sum I runs from 1 to n of x what I. Then coming over here, this sum I runs from 1 to n of xi can be written as x1 plus x2 down to xn. So in that case, what I'm now having here becomes that this is 1 over n, expected value of xi, plus expected value of what? X2, plus expected value of down to expected value of what? Of xn. So here is my mu, here is my mu, mu for this one, down to this. It is needless now saying mu1, mu2. Even if you say mu1, mu2, this mu1 and mu2 are equal coming from here. And we can still add them up. So that was why we had no subscript here like 1, 2 down the line. Because even if you have 1, 2 down the line, this subscript 1 and this subscript 2 are equal coming from here, which is here. So the only thing there is to sum it now up to n times, which is n mu. This n outside will cancel that n, and then we have back this one. So permit me to quickly clean here while we go about that of the variance. Permit me to clean here. Okay, what we now have now becomes to show this one. To show this one now, what we are going to do is this. We say that var, that is variance of x bar, is given as variance of sum I is running from 1 to n of xi all over what? Over n. We close the brackets. Remember that when you have something like this, variance of ax, where this a is known to be a constant, this variance of as can be written as a raised to power 2 variance of what? Of x. This is how to express this particular thing. As long as this A here is a constant. Then coming down here and applying the same principle here, this my n here is a constant. So bringing it outside this variance sign, it is going to be squared. And then what I have now becomes 1 all over n what squared. We have variance of expected value or variance of sum. I now is running from 1 to n of xi. We close the brackets. Now, like I did before, this sum I runs from 1 to n can be expressed this way. Then we have 1 all over what n what squared. We now have what variance, open a bracket. We now have what x1 plus x2 plus down to xn, we cover the bracket. So this implies that this is 1 all over n raised to power 2, we open a bracket. Remember that the information we have here is that the variance of x is sigma squared. And this x here, of course, you are seeing is, I still have this x here to mean the same thing. Even though this one we have as what x1, x2. But like what I told you earlier, this subscript here does not matter. Okay? So meaning that here, if you bring this variance inside, you are going to have what? Variance of x1 plus variance of x2 plus down to variance plus what? We have plus to variance of xn. Let me write it here so it won't confuse any of us. So we now say plus variance of xn. Then we close the brackets. Variance of x1 is sigma squared, variance of x2 is sigma squared. So what we are going to have becomes 1 all over n raised to power 2. We open a bracket. We have variance sigma squared for this x1 plus variance for this what? X2 plus down to this my xn, which is equally sigma squared. I will close the bracket. So this time around, we are still summing our variance up to n times, which is the same thing as 1 all over n raised to power 2 for what I have here. Summing this in up to n times is what? N is n sigma squared. And remember that I have n here and I have n squared here. So this will cancel this square here. So what I have here becomes sigma squared all over n. So we have shown that when a random variable x follows normal with mean, mu, and variance sigma squared, that it implies that expected value of what x bar is mu, and then sigma of x bar is mu. Another way of saying this thing is, let me put it this way for you to see. So therefore, permit me to clean here. So what it means is that if x follows normal with mean, mu, and variance sigma squared, x bar follows still normal distribution with mean still mu and variance sigma squared all over n. Take note of these two things. That is what we intend to establish. This follows this. Sure. Then x bar now will follow this. Mu, as mu is here, but here becomes sigma squared all over n. Thank you very much. And do still remember our constant plea with you. Do subscribe to our YouTube channels. We are actually out to make sure we make a difference, a positive difference in you about your understanding of statistics and mathematics. Thank you very much.